direct linear variation is something we looked at, boys, something we looked at briefly last year. It's where, Tim, you're looking for the words varies directly or directly proportional to. They're the key words you'll be looking for in the sentence, in the question. And if I see those words, then I know that this equation is what I'm going to be using. Alright, so I know that I need to use y equals kx, where k will be some sort of constant of variation. They will not give you k, you need to find it. Now if I was going to draw this on a straight line, this looks like the y equals mx plus b equation, but no plus b. What does the b part of that equation tell me?
Y-intercept.
Y-intercept. So if the y-intercept is not there, what does that mean? So your y-intercept is 0. So if I drew any of these as a graph, then they would go straight through the origin. No matter what I drew, they will always go through the origin. So a graph of any of these directly linear variation questions will be a straight line through the origin. I'm going to do only one question where I ask you to draw it. Pardon? The origin is 0, 0. Right? Because you've got this no intercept here. So there's no y-intercept or it equals 0.
Where's B?
Where's
F and where's K?
K is what in this picture? So think about the straight line, y equals mx plus b. B was our y-intercept.
Oh, the gradient.
Well done. K is the gradient of this line. Okay, so this line will have a gradient of K. Now, if they are directly proportional to each other, if I double X, I will double Y. If I triple X, I will triple Y. If I halve X, I will halve Y. Don't make that noise, please. So that's what directly proportional to means. Whatever you do to one, the same thing is going to happen to the other, varying by this constant. Let's look at an example of how I would do it if I was giving a word problem. So in my question, I'm going to be given that mass varies directly with the volume. Guys, come on, stop talking. Alright, let's go with this example.
Is that the same thing?
Yeah, same thing. This is just the example. I'm just having a shocking writing today. Okay, so we're looking at the mass, which we're going to use the capital M for, varying with volume V. Now, in these sorts of questions, they always give you an example. So they're going to say a mass of 60 litres, a mass of 60 litres of petrol is 42.
Come on, mate.
Guys,
What is after the V?
in litres. Okay, so the mass of 6 litres of petrol is going to be 42 kilograms. Now, because I'm seeing this word varies, I immediately know that I'm going to use the rule y equals kx. Except there's no y, there's no x in the question. What have they done to try and trick you?
M, V.
They've called them m and v. Can we cope with that?
No.
I'm pretty sure we can. So instead of being y equals kx, we're going to say m equals kv. Can we cope with that?
Yeah.
So, Miss, so you're saying if I was to lift a 60 litre tank of petrol, it only weighed, is that 42?
42
kilos.
kilos. Well, they kind of made up, so I don't know if that's actually true. So I know that the rule must be m equals kv. They've given me these numbers. If I put those numbers in the correct place, I can find k, which is my constant. So which one goes where m is? Careful, 42 goes here. And the V will be 60. So if I'm looking for K, what should I do? Divide by 60. So K equals 42 divided by 60. You grab a calculator. A mass of 6 litres of petrol is 42 kilograms. Does that sentence make sense? Got it?
It's 0.7.
So if I do,
Miss, don't you trust me?
I'm sorry, I was already typing, so 0.7. What happens then is I can put that 0.7 into the equation. So my equation is now M equals 0.7 V. Shh, quiet. Someone listen. Oliver. This equation can now be used for